Hello my dear students. So in this video I will be discussing theorem 1.5, 1.6 and 1.7 from the chapter real numbers, because if you don't have the clear concept about the theorems, then we will not be able to, you will not be able to apply this theorem in solving problems from exercise 1.4. okay. So we will just briefly discuss these theorems. Okay. What does this state? It states that let x be a rational number whose decimal expansion terminates. Now suppose a rational number, if I have taken 2 by 5, it's a rational number. Now what they are telling, that if the decimal expansion, if I convert it into decimal and if it terminates means it ends up. So in this case, see 5, 0.54 is 20. So it is terminating, means it is ending up. But there may be some cases where it may not terminate. Okay, suppose it may be 1 by 3. Okay, so in that case 0.333 it goes on, isn't it? It is not terminating. Okay, so what they are telling, if the decimal expansion of a rational number terminates, if terminates, then it can be expressed in the form p by q with p by q, where p and q are coprime. Okay, so they are telling that if something decimal expansion is terminating, then the rational number which is in the p by q form, in this one the denominator, the q can be expressed in the form 2 to the power of n, 5 to the power of m, where m and n are non-negative integers. So you can think of any rational number if it is terminating. Okay, if it is terminating, here it has terminated after after one decimal point. There may be cases where it may terminate after 2 decimal, 3 decimal places, but the main thing is that it is terminating somewhere. Okay, so if it terminates, then definitely that rational number will be having the q in the form, q means the denominator will be in the form 2 to the power of n, 5 to the power of m, where m and n are non-negative integers. Okay, any rational number which is terminating will definitely have the denominator in this form. Okay, so this is the first theorem, means the theorem 1.5. Now in theorem 1.6, what they are telling, this is just the reverse of this one. They are saying in theorem 1.6, here they are telling that suppose we are having a rational number whose denominator, whose q is in the form 2 to the power of n, 5 to the power of m, then definitely that will be terminating. Okay, then that decimal expansion of that number will be terminating. Just the reverse of this one. Here it was told that it is, if it is rational, if a rational number is decimal expansion is terminating, then the denominator will be in the form this. The reverse in theorem 1.6, if the decimal expansion, if the rational number is in such a form that the denominator q is in the form 2 to the power of n, 5 to the power of m, it means that if we do the decimal expansion of such a number, definitely it is going to terminate. Okay, it will not be in such form 0.333, it is non-terminating. Okay, this form will not come, it will definitely terminate. Now the same thing here in theorem 1.7. Okay, 1.7, what they are telling is that we know that if suppose a number x is equal to p by q be a rational number such that prime factorization of q. Here they are telling that suppose your q, okay, a rational number is there x, where the numerator is p and the denominator is q, and the decimal expansion, not decimal expansion, this q is not in the form 2 to the power of n, 5 to the power of m. Suppose it is not in the form, then definitely the decimal expansion will be non-terminating repeating. Now what does this mean? Non-terminating means it is not going to terminate, it is not going to end up, but non-terminating repeating. Suppose 0. Just in the earlier case we have seen 0.333, here it is non-terminating repeating. Here the q is not in the form, it is not in this form, So it means that it is non-terminating repeating. Mind it, there is another type of decimal expansion also where it is called non-terminating non-repeating. Suppose 1 0 1 0 0 1 0 0 0. Okay, this type of numbers. Okay, these are called non-terminating non-repeating. So it means that if you are having this type of decimal expansion which are non-terminating and non-repeating, they are not rational numbers. Okay. So from these three theorems we are getting some basic ideas that if a rational number has terminating decimal, then its q will be in the form 2 to the power of n, 5 to the power of m. Again, if a rational number is having q in this form, then it means that it is going to give you a terminating decimal. And in 1.7 they are telling that if a rational number is not having its denominator in the form 2 to the power of n, 5 to the power of m, then it will be giving you a decimal expansion which will be called as non-terminating repeating. Okay. So it will be more clear while we do some sums from our next exercise, that is exercise 1.4.